Hello good people, I'm going to talk about division of terms. Let me start with this yellow line. It has a length designated d. Suppose that I divide it into 4 equal parts. How could I express the length of one of these parts? So this blue section here. I could say that I took d and I divided it into 4. d divided by 4 can also be expressed using fractional notation. When we have a fraction, the line in the middle is known as the division line, and mathematically it serves the same purpose as the division symbol. So d divided by 4 could be written as d over 4. The truth is that in mathematics and sciences, we tend to prefer the division line over the division symbol. In other words, we like to deal with fractions. How else could I express this d over 4 or d divided by 4? It is the same as 1/4 or 1 over 4 multiplied by d. And that kind of makes sense. Essentially, I'm saying that the blue section is a quarter of the entire yellow section. Pardon me, yellow line. And if I did not like fractions, I could convert the fraction into a decimal. 1 over 4 or 1 divided by 4 is same as 0.25, so I would have 0.25d. So, an unknown variable can be divided by a constant. Let me bring in another line. The length of this new yellow line is 2d. I'm going to divide it into 4 equal parts. Now I'm interested in the length of the green section. So I could say that I have 2d that I have divided by 4. Using fractional notation, I could have 2d over 4. And this can be rewritten as 2/4 or 2 over 4 multiplied by d. 2 over 4 is same as 0.5, but in this case 0.5d. So far I was dividing a variable by a constant, but I could go the other way around. I could have a constant that is going to be divided by a variable. Let me get rid of this and bring in this yellow square that represents 20. Maybe it represents an area. The point is that I want to take this 20 and divide it by t. How would I express that? Well, firstly, I could simply write 20 and then the division symbol, so divided by t. However, as I said earlier, in mathematics and sciences, we prefer fractions. So I'm going to draw my vinculum, or my division line, and I will have 20 divided by t. This is as far as we can go. I have simply expressed my division as a fraction. But what if I want to divide my 20 by 2t? So I'm going to place it in brackets. I'm dividing 20 by the product of 2 and t. I can write this as a fraction again. I have 20 divided by 2t. This can be simplified. 20 divided by 2, in other words, I'm dealing with the numbers, is 10. So above the line, I have 10, and the t below the line, well, it remains below the line. So now I have 10 over t. There is a common mistake that people make. So let me rewrite this 20 over 2t. People might say, well, can we not do the same thing we've done previously, as in take 20 and divide it by 2 and then multiply by t? Well, 20 divided by 2 will give me 10 and then multiplied by t. We have ended up with 2 different expressions. The top one is correct, but how could I prove it? Let me test it out. I'm going to say for a moment that t equals 5, and I'm going to see what happens. So firstly, let's deal with it as a simple division. So we have 20 divided by, in brackets, 2 multiplied by 5, because now 5 is t. That will give me 20 divided by 10, which is 2. Let me test out my two expressions above. If I have 10 over t, that will give me 10 over 5 because t is 5, and that is 2. On the other hand, if I go with 10t, I will have 10 multiplied by 2, that is 20. So I can definitely say that the top approach is correct and that the bottom approach is incorrect. Why is that? Well, the 20 is divided by the product of 2t, not just 2 and not just t. If we were to follow this approach at the bottom, we are changing it. We are saying that the 20 is only divided by 2. Let me bring in another example. This rectangle represents 50h. And for whatever reason, I want to divide it by h. What do I need to do here? How do I express this? Well, once again, fractional notation to the rescue. 50h will be above the line and h will be below the line. H divided by h is 1. Recall that anything divided by itself gives 1. So in essence, I have 50 multiplied by 1, which is 50. What if I want to divide my 50h by 2h? Well, in terms of a fraction, I will have 50h divided by 2h. How do I approach this? Well, I divide the numbers by numbers and letters by letters. So 50 divided by 2 will give me 25. H divided by h will give me 1. So I have 25 multiplied by 1, and that is 25. To make it interesting, let's introduce powers to the mix. So let's say that I have 50h to the power of 4, and I want to divide that by 2h. The process remains the same. I'm going to use fractional notation to give me 50h to the power of 4 over 2h. And again, I'm going to divide the numbers. 50 divided by 2 is 25, and h4 divided by h, that is h to the power of 3, which will give me 25 h to the power of 3. Where does the h to the power of 3 come from? Well, remember the power rules. I have h to the power of 4 divided by h to the power of 1. If I'm dividing and the bases are the same, I can simply subtract the exponents, which will give me h to the power of 3. What if it is slightly different? I might have 50h, and that will be divided by 2h to the power of 4. As always, I'm going to write it as a fraction. So in this case, 50h over 2h to the power of 4. Dealing with the numbers first, 50 divided by 2 is 25. What is h divided by h to the power of 4? Well, let's follow the rules of powers again. If I'm dividing and the bases are the same, I can subtract the exponents. 1 minus 4 is negative 3. So I will have 25 multiplied by h to the power of negative 3, which is 25 h to the power of negative 3. To finish this off, let's quickly do a few problems. Okay, let's start from the top. 63a divided by 7, well, I can divide the numbers. 63 divided by 7 will give me 9, but it is 9a. Similar thing with 56b divided by 4. 56 divided by 4 is 14. Do not forget the b. Okay, now we have some powers as well. Let's deal with the numbers first. 35 divided by 5, that is 7. And now I have c4 divided by I have c to the power of 4 divided by c to the power of 2, that is c to the power of 2. Next one, 36d to the power of 3 divided by 9d to the power of 7. 36 divided by 9, that is 4. And now I have d to the power of 3 divided by d to the power of 7. The bases are the same. I'm dividing, therefore I can subtract the exponents. 3 minus 7 is negative 4. Last one. 72e divided by e squared. Well, I still have the 72, there are no other numbers. E divided by e squared is going to be e to the power of negative 1. When it comes to division of terms, we deal with the numbers first and then letters. And while we are doing that, we are constantly keeping the power rules in mind as well. At times, this might result in the letters disappearing completely, or it might result in negative powers. That is all for now, and I will see you on the flip side.